Alright, so what do we do if there's a quadratic function that is not in standard form? So a quadratic function is its graph is a parabola and it has an x squared in it. And its standard form, if you recall, looks something like y equals some constant a times some shifted x quantity squared plus another constant. Usually we write this as x minus h quantity squared to get our x coordinate of our vertex, and we write plus k out here to get our y coordinate of our vertex. So this is our goal, to write our equation in this form, and clearly what we'd have to do is complete the square on the x part of the function to get this thing to happen. So let's look at an example. So here's a quadratic function which we can recognize because of the x squared. However, finding the vertex of this is not terribly easy. It's not in the standard form that we have up here. So what we need to do is we need to make this x squared minus 6x, the x part of this, look like this sort of thing. Alright? And as we do this, we need to make sure the equation stays balanced. Alright? So f of x equals, every step we have should be f of x on the left side. F of x equals, and what I'm going to do is sort of isolate my x's, and I have to add something to these two guys, some constant to this, to make this a perfect square. That's our goal, to make it a perfect square trinomial so that it will factor like this. So I don't know what to add yet. I've got my plus 13, and I'll have to do something else on the end of this to keep it balanced, right? If I add something here, then to keep this equation balanced, I'll have to subtract it over here so that those would cancel out. I have to basically add 0 to this whole thing, which we'll see in a minute. So what we're going to do is pretend that this is already a perfect square so we can figure out what to add. So to get x squared, I'd have to have x and x, and to get the negative 6x in the middle, I'd have to have a minus 3 and a minus 3. And now we can see that the constant we would add would be the negative 3 times the negative 3 to give us a positive 9. And now this is a perfect square trinomial, and you can see how it factors. If I add 9 here, that is not the same thing as what I have up here, right? I've got this extra 9. So to counteract that, I need to come on the end of this and subtract 9. And basically we've got two things now. We've got this trinomial, which is a perfect square, and we have the constant out here. So the constant is going to be this k part of the function. Alright, so 13 minus 9 is 4, and all I have left to do is write this as being squared as it is up here. So f of x equals x minus 3 quantity squared plus 4. And so that looks just like this, except we're missing this a, right? So if you don't know what that is, it's simply a positive 1 if you want to write it on there. And now you could find the vertex. The vertex would be positive 3 comma negative 4. Sorry, positive 3 comma positive 4. The vertex is 3, 4. This number in front's positive, so it opens up, and that vertex would be down here, 3, 4. So the vertex would be a minimum point for this particular parabola. You can make lots of connections from this. You could graph it more precisely, etc. But what we're focusing on here is how to write the original function into this nice little standard form. Sometimes it's called vertex form. So here's another similar example, except now we have this negative in front of the x squared. You might notice that up here only x is squared, nothing in front of it. So what we have to do is anytime there's a number, a constant or something in front of the x squared, we have to factor it out of the x part of the equation. Alright? So sometimes that's difficult. So what we're going to do is we're going to factor a negative out of the x part. So I'll have negative quantity x squared plus 6x. And then I always leave my constant sort of hanging out here to mimic the k up here. Now I need to go in here and make this a perfect square. So I'll sort of go inside these parentheses and add something to the binomial, copy down my negative 11, and I'll have to do something here to balance what I do here. But before I can do that, I have to figure out what I have to add. So I copy my negative and I start factoring the x squared plus 6x as if it were a perfect square. I'd have x, and to get the positive 6 I need a positive 3 and a positive 3. And once again, 3 times 3 is 9, so I have to add a 9. Now the big difference between this and the last one is that this 9 is multiplied by negative 1. So really what I've done by putting this plus 9 here is I've really subtracted 9 on the right side. So to counteract that, I need to add 9 on the end. And now I've subtracted 9 and added 9, so the right side is exactly what it was before. It just looks different. Now I can go down. Negative 11 plus 9 is negative 2. I get my constant on the end. And finally, I write x plus 3 squared minus 2. And if this negative throws you off in the front, it's also a negative 1. So your constant in the front is negative 1. You could find the vertex, you could graph it, you could determine if it's a minimum, maximum, etc. We'll do one more example here. Similar to the last one, we have to sort of separate this 2 from the x squared. So to do that, I'll factor a 2 out of the x part of this. It's very tempting to factor 2 out of everything, but no, we want to complete the square in x, so we leave this constant floating out there like this k, okay? So be careful with that. So we'll factor 2 out, and we get x squared minus 2x plus 2. Now we work inside the parentheses on the x squared minus 2x and add something to it to make it a perfect square. Copy down the plus 2, and then I have to counteract whatever I do inside the parentheses. Now I start factoring the x squared minus 2x as if it's a perfect square. I need x and x to get x squared. To get negative 2x, I need minus 1 and minus 1. And negative 1 times negative 1 is positive 1, so I add a 1 here. By adding this 1, it's actually multiplied by 2, so I actually added 2. So on the end here, I need to subtract 2 to counteract that. So plus 2 minus 2 is actually plus 0, if you want to write that. Finally, I end up with 2 times x minus 1 squared. And if you want, you could write plus 0, but it's not necessary. But it is helpful in finding the vertex. The vertex of this would be 1, 0, and the parabola would open upward because this 2 is positive.